Hey there, we are going to be looking at rational expressions today, and the first thing that we're going to look at are restricting the denominator. So let's get right into it, and I can explain what exactly I mean by all these words you've probably never heard before. Alright, first off, a rational expression. This is the quotient of two polynomials. Remember, quotient means divide, and so we're just going to be dividing two polynomials, and 95% of the time you're going to see these, they're going to be written as fractions. So for instance, 2x divided by x squared, 5x to the third divided by x minus 2, or x squared plus 5x plus 6 divided by x squared plus x minus 2. All of these are rational expressions because these are all polynomials in the numerators and in the denominators. Some of them will be very simple, some of them might be a little bit trickier, but they all follow the same basic rules. The first of which is we cannot divide by 0. If you remember, anytime you try and divide by 0 in your calculator, it'll give you an error, and we cannot end up with 0 in the denominator of a fraction. So what we're going to have to do is we're going to have to figure out what numbers would make their denominator 0. Alright, when we are looking for what numbers make our denominator 0, what we're doing is we're solving for the domain. At the very beginning of the year we talked about domain. Domain is all of the numbers you can plug into something. So what we're trying to figure out is what numbers would, when we plug them in, cause problems for a rational expression. So what we're going to do is we're going to take our denominator and set it equal to 0. So we're going to have whatever our denominator is equals 0. We're then going to solve for x, solving through every way that we've done before through regular equations. Whatever we find is going to tell us what our domain is, because the domain is all real numbers except for what we found. So for instance, if you solve and you get x equals 1, then your domain would be all real numbers except 1. And the way that we would write this, we've got a fancy little symbol to represent all real numbers, since we don't always want to write all of that out. So an R with 2 bars on the back side here, that means all real numbers. So if we wanted to say all real numbers except 1, we would just write this fancy R except 1. So this would represent all real numbers except 1. Let's take a look at a couple examples. All right, these are the 3 same problems that I had on the second slide, and we're going to go through and find the domain of each of these. So this first one here, I'm going to follow my steps. First, I'm going to set my denominator equal to 0, and then I solve. I solve by taking my square root here, the square root and the squared cancel out, so I just get x. And the square root of 0 is 0. So my domain here is going to be all real numbers except 0. And I'm going to move this up just so I got room to write that. So I can plug in literally any number I want to into this expression and get some result except for 0. If I plug in 0, then I'm going to have 0 in my denominator, and that will cause an error. Before we take a look at this second one right here, some of you are probably thinking, well, we didn't do anything with the numerator. We don't really care about the numerator for the domain. We don't care if we get a 0 on top. We don't care if we get a negative number or a positive number, but we need to make sure that we don't have 0 in the denominator. So whenever we're solving for the domain, we don't actually do anything with the numerator. It's only the denominator that affects this. So here with this second one, I'm going to just do the same thing. I'm going to set my whole denominator equal to 0. And then I'm going to solve. I'm going to solve for x. So I'm going to add 2 to both sides. And that'll give me x equals positive 2. So that means my domain for this is all real numbers except for 2. So that means I can plug in any number I want to, except for the number 2, and get some result. This third one here might look a little bit more complicated, but if you remember the factoring that we reviewed, this shouldn't be too difficult. What I'm going to do is I'm going to go ahead and factor this, and I'm going to take the shortcut here just for time's sake. I'm looking for two numbers that multiply to -2, add to +1. Well, that's +2 and -1. So I have these two things equal to 0. Now what I have to do is I have to set each of them equal to 0 and solve each of them. So if I solve these out, I'm going to end up with x equals -2 and x equals +1. If you're having trouble following my steps here on how I'm getting this, please raise your hand and ask me. I will come around and explain this to you. But we get two answers here, which means these are both exceptions. So we would say our domain is all real numbers except for -2 and +1. So I can't plug either of those in. I can plug in any number except for -2 and +1, and that would be my domain.